Okay, awesome. Okay, German, would you like to go ahead and introduce yourself?
Yes. So my name is Germain Garreau. I'm a French researcher. I'm a postdoctoral researcher at the ETH of Zurich. I don't know what it means, the ETH Institute of Technology in Zurich in Switzerland. So I am a recent doctor in astronomy and astrophysics. I actually graduated only in September last year.
Wow,
So I've been a
very
postdoc
fresh
for a
then.
couple of months.
Fresh out of the oven.
Exactly. So very new in the big family of astronomy. Yeah.
Right.
And so yeah, I started my postdoc so very recently now on the Life Mission project. So the that is based in Zurich. So it's a space mission project that is for like the far future in like the 2040s, 2050s, but it's a mission that is planned to try to observe and characterize like potentially habitable planets, so
Right.
potentially looking for Earth 2.0. So very exciting projects that we have at the moment.
Yeah, right. Okay. That is fantastic. Okay, so I think because you have a very exciting path and journey in astronomy, which is also like not very common for everyone, like at least like on this channel so far, then okay, so let's dive in to the very first question and ask you that how did you become an astronomer slash someone who is like doing like optical engineering, instrumentation, etc.
Yeah, yeah. So indeed, like I consider myself as an astronomer, but I mainly
Right.
do instrumentation work. So I work, my work is to design instruments for exoplanets detection, exoplanets characterization, trying to get more information about the exoplanets we know, but also trying to find new exoplanets that we don't know and try to map a bit what kind of planets in the universe there is. But yeah, my day-to-day work is more on instrumentation. It's a very lab type of work,
All
but
right.
it's not like so. I was not really aiming for this at the beginning. So like at the beginning, I just wanted to do astronomy in general. So it's
All right.
the story is like I come from the countryside in France, and so it's just like I had a beautiful night sky back at
Mm.
my parents on the garden, and it's just like looking at the sky, I was really inspired, and I always wanted to be an astronomer, like since I was very little.
Oh,
So it
like what
started
age
like
was
this.
this? Do you have like a vivid memory of this that like, oh, you
I
were like
have.
5 years
I
old and
really,
then
I clearly remember the moment. I remember it was an evening in winter, and we came back
right.
from my grandparents for like maybe some
Mm.
Christmas event or something.
Right.
And then I stepped out of my parents' car and I looked at the sky. But I think for the first time I remember this, and it was mesmerizing. Yeah, I really have a clear memory of watching the night sky at the moment and having the idea that I wanted to study this in the
Right.
future.
How old were you back then?
Maybe 12. I went to like a
12.
different
Okay.
steps of jobs I wanted to
Right.
do, but this one was like the last job I wanted to do, and I kept
Okay.
this one for the rest of my life.
Oh, okay. What were
So,
the other options? Was it like a scientist,
oh,
professor, or
my
like
first one wanted I wanted to be a train driver.
oh,
So
then you were very
it was
little, I
very
imagine.
different. I was not so my I
Yeah.
don't come from a very scientific family. I
Oh,
actually
okay,
come from
right.
like a very family of farmers and stuff.
Oh,
So
okay,
I
right.
was the first
True.
one in my family to pursue like higher education at this point in
Wow.
university and go
Oh,
to
wow.
so it was all very new
Right.
for my
And
parents to
especially, I mean,
do.
like your field, because I mean, it is like something that is like, I mean, somewhere like in between engineering, astronomy, etc. It's like kind of like tech-based as well. Like,
Yeah.
I actually like believe that your parents are both like scientists or like doing something that has to do like with the university or higher education, but
No,
very
it happens
interesting.
that indeed people who are pursuing like higher education are coming already from like a
Right,
background of like teachers, of
right,
engineers, teachers, doctors. So
mhm,
they already know a bit the field and they can navigate it
right,
easier. For me, it was very difficult to navigate because
right,
the moment I knew I wanted to do astronomy, since my parents couldn't really help me to know what to
right.
do, and we didn't have much internet when I was young, so I couldn't like I didn't have this idea of going on the internet. So I went to the
Mhm,
school counselor to ask, so I would like to do astronomy. What kind of studies
mhm.
should I do? And
And
the
what was
answer
the age that you did this? It was like
Oh, it
15,
was
15,
when I was in
16,
high school, so like close to maybe 16, 17,
16,
like
right.
the moment where you need to decide what to do after
Right.
high school,
Okay.
and like if you want to
Right.
go to university or like
Okay.
another school. And the school counselor, I clearly remember, it told me that there was a very nice school about telecommunication of satellites. And
Wow.
I went out of the office of the school counselor very, very disappointed because I didn't get any advice of what I actually wanted, which was
Okay.
like pursuing
Right.
like an astronomical
Yeah.
research.
Right.
And it's like people didn't understand what I wanted. I was talking
Right.
to my teachers. Most of my teachers told me that it was an impasse, like I shouldn't pursue such research because
Hmm.
I was not going to make it, or it was very
Oh.
difficult, very,
Oh.
very like that it would lead me to like an employment probably or something like this. So
This
I
could be
had a
true.
very
This part, but is it because like you didn't have like high grades in like physics or math or something, or like
I had good grades, but I think I didn't have like good
a
enough grades so
stellar?
that people could think that
Yeah,
I would
right.
pursue
Okay.
something like so like
So
maybe precise.
big.
I
Yeah,
don't
no,
know really
right,
thought
true.
about this. No, I didn't have much encouragement of
Right,
in the school within the school.
right.
And then so I kind of followed when my teachers were telling me is that, oh, you have good enough grades, so you should go to like these like engineer background, like you should
Okay.
go to like engineer schools because these
Right,
are like good schools to have a good job.
right.
And so I kind of followed this
Hmm.
advice, thinking that maybe at some point I could like switch to astronomy if I wanted to.
Okay.
And so that's how I ended up in engineering at the end. So I did
Okay.
like this
Right.
in France, we have these 2 years of preparatory class where we
Okay.
prepare for big exams so that we can then choose the engineer school we wanted to go to.
Right.
So I already in these 2 years of preparation, I wanted to do astronomy, but like it was steering me in the very wrong direction. And so after a few years, I ended up in this engineer school in Grenoble.
Right.
And the very sad story is that my hope, this engineer school was proposing some astronomical courses, like
Right.
for engineers, because Grenoble is a very hub of like instrumentation for astronomy. There are
Right. True.
big connections between astronomers and
Right.
engineers there. Like many instruments were made there. But the year I started to study in this school, they stopped this program of astronomy, or like they said, like
Wow.
it's only if you have like unimaginable good grades, then that you
Yeah.
could do that, which I didn't. So
Right.
I couldn't pursue this. So that
Jesus
was
Christ, like how many obstacles did you have? You had like very mean teachers who really like didn't encourage you. This was the
I also
second
had
time
good. I had
they stopped the astronomy.
no, I had a couple of teachers. Like this is the important. I'm not the first one to like get a
Right.
lot of obstacle to like do what I want to do. But like the important thing is not the people who are discouraging you. They are the people who are encouraging you. And I had a couple
Okay.
of good teachers who really helped me and like provided me with good advice. And these
Okay,
ones I
right.
remember a lot more than the other teachers.
This
So
is actually, yeah, like very nice part of it. Yeah, no, right. Because I was like, okay, so
you
you were
yeah.
discouraged and then you ended up in engineering because no one like encouraged you to like go towards like astronomical
Or I just
studies,
didn't
kind of.
have advice because I actually now realize that I could have just gone to university and like follow
Right.
a master of astronomy and astrophysics. But this is like it's a very French thing, is that in France it's very
Yeah.
discouraged. Like it's really not goodly viewed to switch your career around.
Okay.
Like you're
Right.
really
Ah,
encouraged to continue your career at
okay.
the like and not change it, like steer it in another direction because
Okay.
this is like not very common and not very
Okay.
appreciated. Yeah, on the contrary, like other countries are really seeing like in a good way if you
Right,
tried like
true.
going to university, you didn't like it, so you change your job, you change something else, and then you have a lot of experience in many
Right.
things. This is
No, they
not the case in
usually see it
France.
as a sign of like competence. If you can like navigate different environments, or you're usually like very clever if you can just like go like from field to field and you can like handle your business still. I feel like that's a great point, but then yeah, like I didn't know like
Right?
the
Yeah.
French thing. Yeah, no, right.
Right, I really think so. It's a very strange thing we have in the French system is very steering you in one direction and motivating
Right,
you to continue the furthest in one direction.
right,
So so it was yeah, my path to astronomy. So the way I did it is that I was in this engineering school feeling very depressed at the moment, the moment I was in there, because I was not studying things that interested me.
Right.
But I did have one class with an astronomer. It was for one semester, we had one class to study like astronomical instrumentation. I had a very good teacher there, which I was very happy with the course. But I was so depressed at the moment. I was so
Mm.
convinced that I couldn't do it that I couldn't imagine asking him to like
Oh,
visit the labs, go there, talk with them
right.
about like the possibility to start an
Oh,
internship.
yeah, no, right.
I
True.
didn't even consider this as an option anymore at this point
Right. True. Okay.
until the moment I had to find an internship,
Okay.
and I couldn't find one. So then I sent an email to this institute, and this teacher replied to me. The
Right.
teacher I had replied to me to say, "Hey, we have a potential internship for you that if you're interested, you could like
Right.
do it as a master thesis."
Okay.
And then I was
Wow.
taken, and that's how I entered like the field of astronomy. I had a master
Oh, wow.
thesis on instrumentation, like trying to simulate the performance of an instrument with some
Right.
software. And so that was the way I entered the astronomy, because then after this master thesis, I could
Mm.
apply to a PhD that was quite
Right.
close to the master thesis I did. So then I went to Belgium to do this PhD.
Right.
And then after the PhD, now I'm doing a postdoc also like on the same field. So
Right.
this is how it all started. But it really feels like an accident to me that I entered astronomy, because I
I'm
didn't
actually
have.
thinking about this. So, like, what was the conversation behind this? Like, did your teacher said something specific that they saw something, I don't know, special on your CV that they trusted you to do this project for
Well, I
astronomy? Like, how did it start?
uh,
Did you look for projects that were astronomical oriented or something like that?
I
Like,
did
were you
look for it.
actively looking
And,
for it still?
sorry?
Like, were you actively looking for something that was still related to astronomy, like after so many years?
Yes, I was trying, but then I
Right,
didn't get many answers. And I
right,
think it's just because I had this class with this teacher. I
right,
also, since I really liked this course, I also ended up with like a very good grade. So
right,
I think that's how at the end they thought like I was maybe a good option to take for this
right.
master thesis. And yeah, indeed, I was very motivated. As soon as I got
Right.
this master thesis, I was then very motivated to prove that I
Oh,
was
nice.
interested, that
Oh,
I
wow.
wanted to prove myself. But it all felt like very out of
Out of
nowhere,
nowhere. Yeah,
out of nowhere,
right.
because
So out of the blue, yeah. I got
it's
this
like
internship.
when during all your studies people tell you like you're not matched for this, you're like you can't really do it,
Yeah,
like this is not
right.
something for
For like
you,
so
and
many
then you all
years.
of a sudden have an opportunity, you can do it, and then you can do it good. I had a good grade on my master thesis. I had like good reference letter to start applying for a PhD. And so at this point, yeah, I have to say, I don't really understand why so many people were trying to dissuade me from pursuing this research, because
Right.
it's also really not a dead end. Like, even if
No,
you don't want to continue in astronomy after doing a PhD, it's not
right.
a dead end. You can
No,
switch to industry. People
right.
really appreciate the experience you
Right.
gather
True.
during a PhD. So it's really, even if in the end it's hard to find a permanent position in
Right.
astronomy, and in research in general, it's quite hard to find permanent
Right.
position. But it's really not a dead end. Nobody is ending up unemployed after
True.
this.
This is very true though. Like this is I'm so happy that you brought this up. Like I don't know any astronomers who have ended up unemployed. Like you end up like I mean actually a very good job. Honestly, even
Yes.
in industry, like you never start from scratch. They always like give you like type of jobs that needs a very big brain, all right, because they know the level of your patience and then like how skilled you are and how much you have invested in yourself for like so many years, I believe. But I mean, from an emotional point of view, I find your story very inspiring, because all these years, I mean, that people were like dissuading you from like, I mean, going after what you wanted because they thought like it is like very hard for you. But I think in a very special place in your heart, you always had astronomy sitting somewhere. Like it was always like at the back of your mind. Now, like one day I'm gonna go and then like I don't know like how somehow like reconnect with the field and then become part of it, so it was always there I think. And then like when
Mhm.
when when it was ready for you, like I mean luck is usually opportunity meeting the skills or like whatever like motivation or like something like that. So yeah, like, it was a lucky situation, but yeah, I think it's amazing that like you just like did a transition like this. It was like, oh yeah, like
Yes.
I'm still unhappy. I went to the field that they asked me to go to because of my grades and then like how they felt about me. But yeah, like it just happened and then I was in the right place.
And it's never too late. I have to say, like the good thing with like astronomy, like instrumentation in
Right.
astronomy, is that no matter your field, you always have like if you're interested in astronomy, you can always enter. Like I entered as an optical engineer, that was my
Right.
background, but we're also hiring electrical engineers, software
True.
engineer. We need every kind of engineer when
Hmm.
it comes to building an instrument because we can't be experts of everything, and we need like the more developed and technical these instruments begin, like the more we need
Right.
engineers in all aspects of like material. We need material engineering, we need yeah, software
True.
engineering, electrical engineering. Any kind of this is like crucial, and actually the people who are not coming from a background of astronomy are very appreciated too because they
Right.
bring something a bit different, and they are usually thought to be very competent for building instruments.
Right.
So usually yeah, in instrumentation for astronomy, people kind of prefer usually to hire people outside of astronomy rather than people who had a master of astronomy, who did a bit everything and a bit of
Right.
instrumentation, but lack a bit of background in these
Right.
fields.
No,
So
this is great conversation. Yeah, I think like so many people just don't know this. They're like you grow up as an astronomer, like even when you're like at a high school, like you have some type of connection, then you get a bachelor in like physics or astrophysics, and then like you do like astronomy masters and then like PhD, which is usually the continuation of the master thesis, like something like that. It didn't work like that for you. So it wasn't like completely linear, and then like you ended up in a place that never like satisfied you emotionally speaking. But yeah.
and
So like
it's never too late.
yeah.
I have the example of like very recently,
Right.
in Australia, they started like developing a new instrument, and the leader for the optical design of this
Right.
instrument is a postdoc, but who did a his PhD in something that is completely different, like that was in
Wow.
artificial intelligence.
Oh,
So completely outside of astronomy, and then he was
right,
taken as like a postdoc for leading the optical
right,
design of an instrument, and like leading the
true,
science, the development of the instrument to see what kind of science we can do with it. So a
right.
job with high responsibility and without any knowledge of like
No,
astronomy in
true,
general. And I find that very interesting because it feels like the field of astronomy is opening up to people of very
right,
different kinds of
true,
backgrounds and making it like a lot richer than when everyone
right.
was going through the same master of astronomy and then doing master thesis and PhD in like the very usual way.
No, th this is absolutely true. Yes. And especially because we're becoming part of all these like big collaborations. We are like, I mean, enjoying like peoples of all types of skills. And then like it is also like becoming way more collaborative rather than competitive, I guess. Although the positions are not catching up with the number of the people who are like coming in. But at the same time, yeah. I think like, this is great. Like I didn't know like even after your PhD you can do
Well,
the transition. So it is like great to know. Yeah, like this is the first example that I'm hearing.
what you're saying, the fact that there's not enough position to follow with the number of applicants, this is
Right.
actually the opposite when it comes to instrumentation. We don't
Oh,
have enough
wow.
applicants. Like for my
Really?
PhD, we were
Right.
only two applicants. They were like really relevant. Like there was
How
me and
many positions were there?
there was like one position
Yeah.
in like for like instrumentation, and we were
Right.
only two candidates for
Oh,
this
wow.
position.
Oh my
But it was the one that was really like going for pure
God.
instrumentation,
Right.
almost engineering. There was another position at the same time, which was more
Right.
about like what we call data reduction, that is a bit more like
Yeah.
software work,
True.
also
Right.
instrumentation, but a bit more software. And there were like
Right.
more than 70, I think, applicants for this one.
Oh yeah, like
So
pipeline development, I
difference
think
is
is a very crowded field. Yeah,
so
everyone's
exactly.
developing some type of pipeline somewhere. Yeah, no, right? No,
So you
true.
see the
That is,
difference,
yeah,
like there are really some niche positions
right,
where there's really no one, and it's
right,
very
true,
easy if you have the profile they're looking for. It's very easy to get a position
right.
in there.
This is like something that I also like hear like from a French guy like very recently. We were in Marseille and he was telling me the very same thing. He was like, "Oh yeah, like I just like sent out my application." He was also doing like instrumentation. So it was like they just like looked at my profile and they were like, "Okay, you're fit for the job. Come over." Like it was like as easy as that, like because I think like we don't have like that many people who do instrumentation. There are not that many people who are also like
No.
interested in the field. And
Mm-mm.
there is also, I think, like kind of like gender balance in that type of thing too. Like for example, like here in Italy, first the degree that you should have in your PhD is like completely different for instrumentation. It is called um experimental physics. So it is not
Mm-hmm.
like, I mean, it is not in the category of astronomy even. Here it is called like astrophysics and astronomy or like space sciences, something like that if you want to do astronomy. But then if you want to go to the lab, like there is a very different degree for that. And also, there are not that many women in it too. And I feel like women are seen like maybe not that favorably too, because they're like always usually the only woman in the room, which is like kind of like breaking the balance or like changing the flow of conversations or like stuff like that. So, yeah, I don't know, like, what is your view about that? Like, how many women are working in the
Very, very
lab
few.
or,
Like in the field of astronomical instrumentations, very few, I have to say. Like,
right,
I only know, like, from the people I know who are working on projects, I only know maybe a handful of women,
right.
like, actually working on instrumentation projects, like, and like, even fewer are like in a permanent position.
Right, true. I mean,
So
when I
it's
visited Nice, I think like the leader of the lab was like a lady, but I'm not sure like how much of the hands-on work she's doing, like for the lab itself,
yes.
though.
Well, I guess it depends, but like it's true that, and it doesn't feel to me that it's getting better, and it will get better anytime soon because all the
Right,
students who are getting for like lab work who are
right.
interested to join for experimental physics in an astronomical lab are all men. It's
Yeah, which is a
basically
pity,
it's
Like
very
for example, I wanted to do that because I was doing like atomic molecular physics when I was a bachelor student and I really loved lab work. But I feel like as you're growing into this field, I mean, okay, like I kind of like changed to this soft research as well. But then at the same time, if there was any opportunity to go to the lab, I would just grab it, Like, but there are not that many. So I mean, yeah, like we don't know, yeah. But I have also like seen some cases, like for example, I was visiting Graz, and then Luca Fossati over there just like showed me the instrumentation for the cute satellite, and then it was a 3D like same size printing of the satellite itself, like the instrumentation part, and he was like, yeah, look at this masterpiece and how it is like assembled, the picture. This is the work of a woman. And I was just like so proud of it. I just like looked at the thing and it was so aesthetically pleasing. I was like, oh yeah, like thank you. Yeah. Like, I never had the opportunity to do that, but I'm very happy that women somewhere are doing this type of job. So yeah, I don't know, like maybe in Europe, like it's the stats are a little bit different, especially because like better than me, like I haven't been like in lab like a lot, so I really don't know. But okay, like what is let's go for the big adventure. So like how was your PhD? Because you were like very fresh, like doing an internship, and then like all of a sudden, like you were in the real game. Like
yes.
and then like it was not any institute too, it was like KU Leuven, which is a place that I believe is like very competitive. They have like very high expectations. And yeah, like I've seen like the thesis that PhD students produce, it's a very high quality. So how was all of that experience?
Well, I think so. Overall, I had a very positive experience
Right.
with my PhD, but like it's not just up to me. Like, right, to have a good experience with a PhD, it takes like a
Right.
topic like that you appreciate, where there's
True.
potential. You need good supervisors. If you have like very toxic supervisors, then you'll have a
Mhm.
hard time enjoying your PhD. And then yeah, you need lots of motivation. Like you need, and then you
Mhm.
need some work from you to carry this PhD and to support
Right.
it. So overall, I was very happy because it was in the nice continuation of my master thesis. So I started my first year not completely lost. I actually had
Right.
some knowledge. I read a few papers already, so I was already in something that I knew.
Right.
And then it was my first 2 years of PhD were really like engineering work. So I was like optical
Mhm.
design of an instrument. So it was a lot of it was a lot of new things. They were very rich years. Like the first year of your PhDs are very intense because you learn a
Right.
lot.
True.
You ask a lot of questions to other people to try to
Right.
understand what's going on. So it was very engineering related. And after some point, I was talking to a few people at conferences, and they were telling me, it's always good for a PhD to have a bit of astronomical side too. So
Right.
aside from engineering, what I call astronomical side is really trying to ask for observation time of
Right.
telescopes or getting some
Right.
observational data and analyzing them and trying
Right.
to maybe publish a quick paper during a
Right.
PhD.
True.
So that, and I think it's indeed important because when you build an instrument, you also want to know what to expect when you're an astronomer, when
Right.
you actually use the instrument,
True.
like what type of data do you want to, what is
Right.
important when you analyze the data. So it's nice to have an overview of like the
Right.
instrument from a like engineer perspective, but also from
Right.
an astronomer perspective. And so I
Right.
was lucky enough that my supervisor had some connections with a few
Mm.
people in the US. So I was
Right.
able to enter a collaboration to get some
Right.
data. And then I could analyze it during my PhD and get a paper out of this, which
Right.
was like my first task really as an astronomer. So
Right.
I can say now that I'm also an astronomer because I also do a bit of observation and I
Right.
collaborate on observations. But and I think these types of profile at the end. So at the end of my PhD, I had, I think, a very interesting profile because I did both like instrumentation and
Right.
also
Of course.
astronomy, which is something that is very positive, a very
Right.
positive experience. Because the opposite is a bit more difficult. When you do a PhD on like really observing data or like
Right.
theory, it's very hard to get involved on an instrument
Oh,
or
yeah.
like
The other
instrumentation
way around
development.
is very difficult. Right.
It's very difficult, and it's most people are actually not very motivated or interested to do that. They rather go in like theories and analyzing data.
I
But
think it's just like so difficult, like if you've done all the like courses and then like software and then like programming, etc. Like you go in a lab and then like you don't know what is what really. Like people like don't know like what is a lens or like what's the CCD or like
or
and stuff
even
like that. And they just like get
they
in there and they're like, oh no, what
completely
is that thing? No, they really don't know, yeah, like what to do with anything, like even like the most basic things because they don't have the background. They have
and
never seen
even
an
I
optical
have
bench even like in fact. So yeah, like they don't know anything.
But even the data, like I have a story that one of my friend who is working on the James Webb Space
Right.
Telescope, and so specifically the MIR instrument that is on board of the James
Right.
Webb Space Telescope, and she was working on like instrumentation, but more like the
Right.
data reduction, like more
Okay.
the type of data that was getting out
Right.
of that. She was helping astronomers to get the data and try
Right.
to analyze them. And she had a meeting with one of the astronomers
Right.
who looked at the data and said, "But the data is shit." And all
I
the
mean,
all the people who
yeah, like
actually
there are
work
some
with them,
JWST instruments which are very
how
controversial.
can you
It's not only
how
Miri, which was down like for a few months or something, but yeah, no, I know. Yeah, like I mean,
and
reality.
how as an astronomer, like how can you talk about this about the James Webb is probably like the most
Uh,
advanced type of
no,
space
it's true.
telescope that
All
people
right.
made, and like tell them that the data they provided is shit.
Yeah, I
Like
know.
so
Well, yeah,
that's
I
why
mean,
like
yeah, you
it's
have
always
this stuff
good.
like going on, yeah, like in all types of work. Yeah, no, I know. Yeah, like I said,
Yeah, yeah.
I don't know. It's like a very difficult environment to navigate like overall and then like you can be like unlucky, I don't know, like some of the best instruments can get something that is like the data doesn't really look good and then it looks very noisy or whatever, but I mean, I know, like it happens, etc. So you had a very good PhD experience that led you to getting a successful postdoc. I mean, the type of job that you also do is like very interesting. So I wanted to ask you a question. So the data analysis that you did was also on interferometry because I believe that the instrumentation type that you're doing is like also like highly focused on interferometry, right? So did you do that like both for the same instrumentation setup or no? Like was it like very different fields?
So that's the it was a bit the challenge, right? It was
Right,
trying to find a project in link with the instrument I was
right,
making. And the instrument I was making during my PhD is not only an interferometer, it's a Nulling interferometer with
right,
is a very niche type of instrument, and there are not a few of these in the world.
right.
And
Do you
luckily
want to
enough,
actually speak a little bit about this? Because I'm sure like there are like some people who really want to know about this instrument because of how controversial, complicated, and complex it was. So do you want to give us a little bit of background?
I can give a short explanation. So
Right,
already, so interferometry in general. So the point of building bigger telescopes is to try to observe the nearest, like the neighborhood of stars. Like the bigger your
Right.
telescope is, the smaller, the more you can resolve two objects that are close together.
Right.
And but the problem is at some point you reach a technical problem is that you can't build bigger instrument. Like at the moment they are building the ELT, the extremely
Right.
large telescope in Chile that will be 39 meters
Right.
diameter. But you can it's already costing like I think a few billion
Right.
dollars. You can and it's exponential, so you can't really
Right.
go at larger diameters. So the solution for that we developed, like not just me but like generations of astronomers
Right.
have developed this solution of interferometry. So instead of using one big telescope, you are using several smaller telescopes,
Right.
and you recombine the light using this interferometry procedure. And using that, you can actually achieve the same precision as a telescope that would be the diameter corresponding to the distance between the two telescopes.
Right.
So if you have two telescopes separated by like 1 kilometers, this is the equivalent of one telescope that would have a diameter of 1 kilometers, which
Right.
is a huge improvement because it's really less costly to build two telescopes separated by a
Right.
large distance rather than one big telescope.
True.
So that's one part of the solution.
Mhm.
But then we still have a problem when it comes to observing exoplanets because exoplanets are very close to their stars. So we can
Right.
start to resolve them with like this interferometry, but they are still very faint. Like we're
Right.
talking billion times fainter than the host
Right.
stars. So even if you can resolve the planet, you will be overshadowed by the light of the star. So you need one way to cancel the light of the star while still detecting the light of the planet.
Right.
And so for
True.
this, we're using the specific technique of nulling interferometry, where
Right.
actually instead of having a constructive interference on the star, we make the instrument so that the light from the star suffers a destructive interference. So it's
Right.
like the light from the different telescope of this from the star is canceling each other and not going
Right.
to the detector, while the light
Right.
from the planet is actually being transmitted and detectable. And thanks to that, we can achieve a stellar attenuation of its light of like a
Right.
factor 1,000 at the moment. But
Right.
we're right now, what I'm doing in Zurich is trying to improve that to a factor like 100,000 in
Oh, wow.
attenuation. And
Wow.
using 100,000 would be good enough to start detecting like Earth-like planets that are
Right.
like billion times fainter
Right.
than the star. Like, not billions in this range, but like yeah, 100,000 star times
Right.
fainter. So that's the point of nulling interferometry. But for
Right.
that, we need extreme precision. Like already interferometry requires a lot of precision, which is
Right.
why it's so hard
True.
to implement.
Right.
It still costs a lot to implement because you need to have a precision on your instrument up to the micrometer level.
Right.
And for nulling interferometry, we need to achieve precision on the instrument that is nanometer level.
Right.
So extreme precision that is required, that is yeah very hard to achieve, and that's what we're working on at the moment in Zurich. So that's why there are very few nulling instruments at the moment.
Right.
So there is only one that is currently operational. It's in Arizona in the Mount Graham.
Right.
And the good thing I had to come back to my PhD is that my supervisor actually developed this instrument in Arizona
Wow.
and is part of this collaboration. So when I
Oh,
said I was interested to have some data, analyze some data,
right.
and it would be good that if it was some nulling data, because then I could
Right.
relate it to my PhD.
True.
It's very
Right.
important when you do a
Of
PhD
course,
to like
yes.
at the end kind of tell a story. Even if the
Right.
story is not true,
Because you're writing.
even if it's
No,
not
but you're
really what
writing
you
a
were planning
thesis,
to do,
right? Yeah.
you need to say a story that shows that
Right.
everything was like very
Right.
smooth
Very
and
consistent.
intended.
Yeah, no, right, true. But also because you're writing a thesis, so like you have to like give a title to all your research, like in one place, and then like you need to read chapters and all that stuff. So yeah. It is exactly a storytelling, so it has to be
It's
consistent. Yes.
exactly, it's always hard if you're really doing two things very different, then it's hard to write it
Oh
and
yeah.
try to link the two topic and
This was
justify
the
why.
problem I had.
Yeah, yeah,
The
yeah.
first part of my thesis was completely something very different from the second part, and my supervisor had a very difficult time like finding a title for it. But he successfully managed to do so, so we just like got over that. But I just wanted to add something to the people who
Yeah.
are like listening because I mean it is one thing to build everything that you sell like on the ground because you have the stability of the ground, etc. But then like you're now working on a very ambitious project that is like sending all of this to the space in the future. I mean, 2040s, like 2050s, etc. So how do you feel
Yeah.
about that? Like being part of
Well,
something that is like so ambitious.
yes, it's very different, especially since the thing we're trying to build right now is basically an improved version of the one I
Right,
was building in my PhD.
right,
It's an improved in any kinds of way, and also the way that it's going to space. It's a good question. So it feels very, yeah, it feels like it's impossible. Like it feels so far to
right,
send something into space, and it feels because like when you build something on the ground, you are allowed to make mistakes. You are
right,
allowed, like you can always come back to the instrument. You can always say, okay, this will be an improvement for later. We
right,
can always change that. We can always come back in 1 year and improve
right,
this. So the constraints are much more relaxed when you're building an
right,
instrument on the ground because you always have more time in the future
right.
to change it. When it's in space, it's one chance
Oh yeah, of
launch.
course.
Like it's a one,
Yeah,
you have one
right,
chance. If it's failing, there's no way to change it.
right,
Maybe some people remember, but when the Hubble Space Telescope was launched, it actually had a default. Like it was, the images were very blurry because there was a focus
right.
problem. But
True.
since it was on a close orbit to Earth,
Right,
they actually could send astronauts to
right.
check the problem.
I know.
But now we're talking about instruments who are on the Lagrangian point,
Right,
which is like millions of kilometers away from Earth. So like completely impossible. Like the James Webb is also located at this point that is very far. So the Lagrangian point is this very specific point where the telescopes and instruments are always in the shadow of the Earth compared to the sun,
right,
which makes it very nice to observe stars because then you're
right,
not having the contamination of the stellar light.
right.
But yeah, this point is very far from
Very
Earth,
far.
which makes it impossible to come back and try,
Right.
oh, I forgot the screw, so I'm gonna come back and
True.
try to change it.
Right. No way to fix anything. Yeah, you should have thought about
Exactly.
everything on the ground. Yeah, and if you have like any technical problem, it's gone. Yeah. Good luck with the
And
next
like
one. And it's
exactly.
I mean like all of these projects they're like $1 billion like at least like type of project. So like if you're messing up something, then you really messed up because the money is not going to like come very easily.
No,
Right. It's a huge
exactly. And
responsibility.
even if it works, it needs to work for several years. So you need
Exactly.
to minimize all the risk in your
Right.
instrument for that. So you need to, for example, minimize the amount of motor, like motorized element you have.
Right.
So
True.
like, and which is a big problem because, as I said, like for nodding interferometry, we need very high precision.
Right.
So ideally, we would like all our optics or every element of our instrument to be with like engines associated so that we can move it, place it at the
Right.
exact position,
True.
correct for small drifts. We would
Right.
like to have as many actuation, we would like as
Right.
many elements
True.
to control. But the more of these elements you add, the more risk you have because like
Right.
these motors are don't have an infinite lifetime. So
Right.
you
True.
actually want your system to be as stable as possible and
Right.
as fixed as possible if you wanted
Right.
to like manage
True.
like several years of lifetime.
Right.
It was a big problem for the James Webb Space Telescope to
True.
resolve this, and this is an immense problem that we also have here in Zurich because we every time we think, oh, this would be nice too, we need to have this element on actuation, but then we
Right.
think in space we can't do that. We need to find another
Right.
solution. So even if at the moment we're not building anything for space, at the moment we're still at the stage of doing prototypes in the lab
Right.
to try
True.
to show that it could work at
Right.
in the space environment. Back in our heads, it's back in the mind, we always have this thing that this idea that it needs to go in space. So we
Right.
also need to make it compatible for
Right.
space operation. So it's always like, yeah, back in the head.
No, right. But I feel like the design part of any type of like satellite or like ground-based facility is one of the most expensive ones. And also like a lot of like workforce and time, etc. like goes through it because it's a lot of thinking and then yeah, like prototyping
Mhm.
and then like testing elements like one on one. Yeah, it's a very complicated work, but I think it's also very motivating because
It's motivating for sure
it's
because
very
when
it's
we're
very
talking,
exciting, I think, because everything is new, especially like the type of instrument that you're like working on, like everything is just niche, literally, because no one has tried this before. And it's a part of
exactly.
a very like big project that is like competing with something else like from ESA that is like proposed and then yeah. I mean it's
It's
yeah.
also very interesting to. It's also what is very nice in my position is that I'm very much in contact with companies. Like we
Right.
also need
True.
companies a lot to develop new technologies. To
Right.
be like, we would need this to work at cryo temperature in space. So like
Right.
at like 0 Kelvin temperatures.
True.
And at the moment, it only works at warm ambient temperatures. So, like, we
Right.
need to be in contact with companies because we don't have enough engineers and enough people in our team to
Right.
develop all of these. And
True.
we need to be up to date to the recent technologies that companies are developing because they may be
Right.
like a new optical fiber that would be perfect
Right.
for what we want to do. So it's also very nice to kind of bridge this these two worlds of academia and industry and try to be in between
Right.
to work on the new technologies. It's very
No, but it's
interesting.
also like great to know that because usually, I mean, parts of satellites also are coming from like different laboratories, which are manufactured inside universities. So like you have like a lot of like labs that are like working inside universities and they're like giving you parts specifically made for a certain satellite or like facility or something. But the more and more like we're advancing, I think yes, there is like this bond that is emerging between universities and companies because the universities don't want to like put that much money into like I mean advancing the industry like alone, let's say. So I mean it's a great thing, I think. I don't know, like, and you think like this is a positive experience for you, also like as a young researcher.
For me, it's definitely positive because like it's always great to have some contact in industry. Like personally,
Right,
I'm not sure to continue in the
right,
university. I am very happy at the moment with the experience I had
right,
in astronomy, and I feel like I would not have a problem to move to industry if I could.
right,
If I find that I don't enjoy my work anymore a
right,
lot, if I find it too stressful, if I want to settle in somewhere.
right.
So it's very nice. I think it's very nice for me to have contacts of
Oh,
company,
of
knowing
course.
people, because then for
Yes.
me it's very useful. I'm not sure. I don't have any opinion on like is it better for like the whole academic research? Is it better to work with companies rather
Right,
than just building the things yourself? I don't have an opinion on that. It's just a consequence to the fact that we have less and less public money and university like
right,
the fundings of university is at best stagnating. At worst, it's getting like it's they're not getting money anymore.
right.
And on the contrary, the industry is getting a lot of money pumped in
True.
by private investors, by
Right,
governments. So sometimes they have a lot of money to explore options that we cannot do,
right,
and so that's the novel things we have with the space mission we're designing is
right,
that it's the first space mission, like the first on this scale that would not be funded by like ESA or NASA or like
right,
public money. So at the moment, we are like we get some public monies, but at the moment we're especially looking for private investors, or at least
right,
like our team is looking preferentially to private investors, collaboration with companies, because ESA is not very eager to help
right,
us at the moment.
right. No, that is actually, yeah, like I think it enriches the academic environment, like whenever you have like partnerships from outside, because I'm very much against the exclusive and then the exclusivatory and then like exclusioning like practices of academia. So I think like opening up and then like accepting that, oh yeah, like other experts can have also like some opinions about your work. Especially I think like the place for that is like instrumentation, engineering, etc. I think like it builds a very nice bridge and then also teaches astronomers to how to collaborate with the outside world, which is a very unique experience, especially because one of the things that I think people really struggle with when they go outside is that they don't have the type of skill set to work in a company or they don't know like how to cope with people. They don't know how to navigate the environment from a social perspective, even to like how to like go there. But then like when you have a little bit of that, when you're still inside academia, I think you're gonna have an easier time understanding like where you're heading at least. Because most of the people that I know, like they were like in an isolated academic environment, and then like all of a sudden they just like transitioned to a completely different environment, and they didn't have like any idea about this like new environment. So it's good to be like even exposed to that type of work, or like yeah, like people who like work in that type of like sector, to just know that whether you like it, instead of just go experiencing and then like maybe that doesn't work for you. And then coming back to academia would be a huge challenge, because if you're gone for like 2 years, it's near impossible to come back for very good reasons, I would say. But yeah. No, as you said, like I think this is a very positive experience. Okay, so I think like this is nicely like laying out the um vibe for the second question. That is like, how do you feel every day about being an astronomer? And so like I mean usually I ask these questions about like, okay, this is not about a day that you're like very hyped. So like I mean your review paper is like published or something like that, like you have a very big achievement, or like you're like coming back from a conference and you're like really hyped. Or one day that your paper is rejected and then like you don't know where you're going with your career. So like on a very daily like average based day, like how do you feel?
Um, hmm. I think, well, I will just repeat. I listened to a few interviews that you did.
Right.
I will just repeat what other people said. Is like
Oh, really?
there's no typical day. Like, and I fully agree with what everyone was saying. Is like there's no
Right.
typical day. As you say, like it's can be you come back from a conference, so you have a ton of
Right.
new ideas that you want to
Right.
try, new collaborations, or the opposite, you can be struggling for like more than a
Right.
week on a problem that you cannot solve, and
True.
you're like struggling, asking everyone around what they
Right.
can do. Like for example, back in the lab where we are at the moment, we have a problem. We've been struggling on this problem for months
Right.
now. So a bit before Christmas, my colleague and I like reached out to a few astronomers and
Right.
instrumentation people all around the world to ask, did you have this problem?
All around the world. Yeah.
All
Come
around the
help
world,
us.
like, yeah,
Right.
people from the
No, because like
US,
the type
people
of
from
work that you're
France.
doing is just so niche. Yeah. Like I think like we have like five experts around the globe and probably like
Exactly, but
answer your
we're
question. Yeah.
reaching all these people and
Right.
asking, oh, back in the 90s, did you have this problem when you made this instrument?
Oh my
Because we're
God.
having this. And everyone reached out to us to
Right.
basically converge to the solution we were like
Right.
thinking, which is a very difficult solution to
Right.
implement. So we're
Right. Of
not
course. Yeah.
particularly happy. So yes, I would say like I can't say like I think this like there's no typical day. What I
Right.
can say is specify maybe for like when you're doing instrumentation, what's the
Right.
typical day we have, typical cycle that we have. So
Right.
typically when you work on instrumentation and in the lab, typically you will
Right.
have an idea, like you
Right.
have something to do, an idea to resolve a problem.
Sure.
Then you contact companies or you order the material you need for
Right.
that. Then you receive the material, you go to the lab, you
Right.
implement, install it on your
Right.
bench, you do some measurements, you try to get some data from that.
Right.
Then you come back to your office, you analyze the data, you try to get some things, and then you start like brainstorming with the colleagues. Like, are we happy with these results?
Right.
What more measurements can we do? Are we do want to
Right.
continue with that? And then it's an iterative process. Like,
Right.
then you get new ideas, you need new to experiment, and then you come back in the lab. So it's a cycle of you never always spend all your time in the lab. You always
Right.
do a circle of like discussing with people, doing some experimentation,
Sure.
then coming back to discuss, and then ordering new materials.
Right.
So it's nice.
No,
It's
thank you so much
Christmas
for
every
bringing
day.
this up. I think
Work
like
is
it is like
normal.
an experience that is not like very normal for astronomers ourselves, but then like also like for the audience too. So like thank you for like painting this picture of like how how you do things like as someone who's doing instrumentation inside astronomy. This
And
is
we
great.
have the good thing, I find it very nice also, is that we have very different questions compared to people who are working on like, models and
Right.
theories.
True.
Typically, people who work on models would be
Right.
like, is my model realistic?
Right.
Are the results I'm getting close to
Right.
what we would have in reality?
Right.
When you're in the lab, it's completely different because you know what you're getting is reality because
Right.
you're measuring the world, you're measuring
Hard
physics.
reality, hardware.
So now the question we have is, why do we not get what we were expecting? Why
Right,
is
true.
it different from what we were expecting?
Right,
And it's very different questions where you cannot say the world is
right,
wrong. You can't say physics is wrong. You,
right.
if you're
True.
getting something different, you must be wrong in this case, or you did something wrong in your
Right.
experiment.
True, right. Yeah, like, this is a very nice way of putting it. Yeah, like no, this is real nice. You're right. You're absolutely right.
And it's so I don't know how people feel
Right,
about like doing modeling and stuff, but really
right,
for me, when I go in the lab and like measuring
right.
like physical things like this, sometimes it really felt like magic. When like in my
Wow.
PhD and even now, it really
Right,
feels like doing magic with light,
right,
like in doing interferometry. So you get interferometry is like you get these fringes.
right,
It's a very typical thing you get is like when you manage your think well enough, when you're precise well
right,
enough, you start to get these fringes of interference. And every day
right,
you wonder, like, is it still going to be there? Because it's such a small thing. It
right,
needs to be so precise. And every day it's still there. And it's like,
right,
wow, it's really magic to see these happening on the
right.
screen of your computer. And yes,
I don't know how you felt about like the very first fringe that you saw or something, but I vividly have this memory inside my head. So I only have one experience of love at first sight, and that is when I was 18. I think I was 17. And then like we were in high school, and I looked at the Young experiment. And it was about like the very first time that you're seeing like light can act as both like particles and waves. And then I very clearly remember our physics teacher said that, oh, you know what? Like you're seeing like light is going on light and you're seeing darkness. And then
mm,
like I just like looked at that thing and I was like, okay, I'm gonna like devote my entire life to this. Like that was the point that I kind of knew. Like I didn't know like how it's gonna be like plasma, like engineering or like I mean some type of like engineer like related to light, something like that. But
mm.
I always knew like it's going to be light and darkness. So yeah, like I mean, do you have like similar experience like that? That like the first time that you saw a fringe or like something in the laboratory? Because I mean, seeing it every day is like great, but then the first time that you saw it for yourself,
So
like how was it?
in high school, I never had this wow effect.
Yeah,
Like I wasn't thinking
right,
about like this. But when it happened for me in my PhD,
right,
when it's actually an experiment I did. Like I thought about all of this. I ordered the material. I installed everything. And at the end of the day, when you spend 2 weeks on that, and at the end you get the fringes
right,
with your own experiment, this is yeah
right,
very moving. This is like the type of moment
right.
you can scream and you can say eureka,
Yeah,
I did
right.
it. And it's
It changes something in your chest, I think. I don't
I
know
think
what's it. It has a very big impact. I don't know what it's
it really
magic,
gave
as you
me a
said.
lot of self-confidence, like when you know you
Yeah,
can do it. And
yeah,
also it's such in this niche field of astronomers who
right,
are working on interferometry, everyone got their first fringes at some point in the lab.
right,
Everyone had to align their
right,
instrument to get the fringes. So it's very a common experience we have and that we like
right,
to share together, is like how what type of experience did you have with the fringes and
right,
stuff. It's really a common things we all have in this very
right.
niche thing that is like
True.
maybe 100 people in the world, but
No, right. Yeah, like that is exactly it. Like not everyone is like lucky enough to go to a lab and then like have this like very first experience to see light behaving
mm,
in this like very strange way. And yeah, like I mean, making it all happen with your own hands, yeah, like it is
yeah,
actually
yeah.
magic. So, I mean, if you have like 5 words to explain yourself on daily basis, like as an astronomer, like how you're feeling, I think the first one is like Alice in Wonderland. It's magic. Yeah.
Magic. Magic for sure, improvisation for sure. Like
Right.
you
True.
don't think about this too much, but when you're
Right.
actually in the lab, you realize you need a lot of improvisation because
Right.
you will
True.
always miss something. There is always something you will
Right.
forget, and
Right.
you like, I need to do it now. I can't wait two
Right.
more weeks for this element to
True.
come. And so you're finding a way to still making it work, and you're
Right.
trying to improvise, finding
True.
something. So lots of improvisation for sure about lab work. Yeah. And I don't know, you said like 5 words.
If you want to go like as long as like
Yeah,
5, but I mean if it is like 2, then like yeah, like magic and improvisation. I think we never had these two things Although like I have like interviewed like many people from like many different backgrounds, like doing, I don't know, like dark matter, dark energy. I mean like kind of like cosmological like type of astronomy stuff. But then yeah, like this is like the very first time that we're like talking about like my, because it is like the lab experience.
Yes.
Like, I totally relate to this. Yes, it is very much like that. Even still, like I mean when I'm like going to a lab, like I always ask people because I'm like supporting a lot of missions. So like I always love to like go to the lab and then at least see like what it is that like they're like going to assemble eventually on the like either like facility or like on the satellite, etc. So it's always a great experience and I've always been like grateful for it. So I mean the last question is that I feel like we touched a little bit on this, but maybe let's see like how it comes out. So how do you see yourself in the future in this field, like potentially speaking, because you also said that you don't have any problems transitioning to industry because most probably like you're going to do a lot of what you're already doing over there as well. And then maybe you're also like getting involved with in academic, like university type of job as well, like producing some like pieces for the university again.
Yep.
So, I mean, like the mental vision that you have for yourself that, like, oh, yeah, like I'm continuing this work. And I know, like, you have a very long postdoc. So, like, most probably, like, you're seeing a lot of things. But in general, like, what is the mental vision that you have at the moment that, like, how do you see yourself in the future?
I I feel like it's quite different. Most of the people I talk to have like sometimes a vision, like a clear vision of how many postdocs they want to do or what they're
Right,
planning to do. For me, it's very difficult to project myself
mm,
in the future, especially like
right,
in the next 20, 30 years, maybe in terms of
right,
career. Like I can imagine, like for now, I'm thinking about what to do in 5 years when I finish my
right,
postdoc. Do I want to continue? But I think it's too soon right now to ask the
right,
question. I barely started. But
right,
in the very far future, it's so difficult to project myself in the field of astronomy and the future of the field of
right,
astronomy in itself, because
mm,
we're in such an unstable like
mm,
political climate. We're
right,
like
true.
first, like we have the big question that keeps me awake at night is what is the place of astronomy with the whole climate change
Oh,
issue?
yes,
What is like
true.
at some point we will get short on resources,
Right,
most probably. And like what is the place of astronomy and these kind of like questions, like big questions of what is life, what is the universe,
right,
where are we in the universe, what place will have these questions in the future when people will start to have trouble drinking water or
right,
like finding food or like.
right,
So this is a very big question that keeps me awake at night. Is also like in at the moment, like when
right.
people are like suffering from war, poverty, and like
True.
starvation, is it morally acceptable to work on something like astronomy?
Right,
So it's very that's why it's very difficult to project myself on like
right.
what will be the place of astronomy in the future because I don't have answers to this. I don't know.
Okay.
I think it will be everyone's decision, the decision
Right,
of people as a whole. Do we keep not just our decision as astronomers, but everyone? Like, do we want to keep
right,
people getting paid to answer these big questions like what is life, what is our position in the universe?
right,
Or do we want to focus resources on something else? And I think both options have good. Obviously, I would prefer to continue doing astronomy, but I would completely understand if people say like we need to stop at some point. We need people in the field to like making some potatoes in the fields. We need people to do other things than that.
right.
And even like in the nearest future, I think like the whole I I was listening to the interview of this Nobel Prize from 2020, I think, Alain Aspect. He was
Mm,
giving an interview on the French radio, and he was
right,
saying something that is so important in research, it's stability. You need a constant like income. Every year you need
right,
roughly the same income to arrive if you want to have research results, and it's the same in
right,
astronomy. You cannot work with like fundings that are on and off. You cannot
right,
work like
true,
with a lot of fundings one year and then nothing the next year and
right,
then again a lot of funding. And so that's why I'm very concerned about what's going on in the US because they have cut a lot of
Right.
fundings. Lots of
True.
colleagues that I know have been like kicked out of
Right.
university. They had like close to a permanent position, but then still they got rid of
Mm.
them. And this has a lot of damage. This will
Right.
cause a lot of damage, not only in a few years, but in a few
Right.
decades. Like lots
True.
of space missions that NASA wanted to do have been canceled,
Right.
and lots of researchers with all their knowledge have left like went for retirement,
Right.
early retirement.
True.
And it's really important to understand that the main resources we have in research is knowledge, the knowledge of people. Every
Right.
time someone leaves academia, they leave with their knowledge, all the knowledge they accumulated for years, and this knowledge
Right.
is lost when people are
Right.
leaving. And it probably will take years or decades to recover the knowledge we've lost with these people who are
Right.
gone. And that's why, yeah, it's hard because it's getting so unstable politically in the US,
Right.
but it might also happen in Europe and elsewhere in the world that
Right.
it's very hard. How are we going to do research? How are we going to do like these ambitious missions in
Right.
such an unstable political environment if one year a government decides to cut all the fundings of
Right.
astronomy and then another government decides to reinstall them?
Right.
So that's why, yeah, I'm not sure I answered your question, but it's for me
I didn't
very.
expect it to like come out as this like heavy. Like honestly, like I mean everyone had like something to say, like even me myself, like when someone like turned around the table and said that, okay, what do you want? Like I had like a response to say that, oh yeah, like I have like that type of thing. But I think if you don't have like any answers, like clear answers for that, and it's still like you're seeing something that is kind of fuzzy, I think it is basically point to a fact that you still have a long way to go. So like maybe like that's even a better thing to do because it's like, oh yeah, like I'm not just going from like point A to B to become either like a permanent researcher or like a professor or something. I have maybe like a second type of journey to like follow. And I think like that's a great mission too. So I mean, you're in the business of habitability. And I think like climate crisis is one of the like biggest issues that all of us are involved with, like kind of like more or less. And I mean, I feel like the biggest mission, the biggest thing that like maybe we need to tell people as astronomers is that there is no planet B. Like, I mean, we're not going anywhere from here. Like, I mean, if we are like polluting all our oceans or in the soil or like whatever, like we're doing irreversible damage to our environment and our home because this is our only home. So I don't, do you want to also like say something about this? Because you're working on life. That is like the mission that is like most probably is going to like find a second Earth, hopefully speaking.
So it's important to say that if like there's never certainty about planet habitability, like we know for
Right,
sure Earth is habitable because we're living
right,
in there. But like even with very ambitious missions like life, we can only get a few clues that
true,
can hint us that maybe a planet is habitable because we're finding
right,
some water, some
true,
oxygen. But it takes so much for a planet to be habitable, and even like hence for humans to be habitable, that the mere idea that another planet would be habitable for humans, it's very difficult. We may never have the answer to this question. We can
right.
only get some clues. So the idea of even going to a planet is like people can try.
Insane,
Like they can
right?
try to make a space mission and like send there's a book I read that about like people making a space mission, a colony,
Right,
and sending it to the nearest star to try to
right.
find if there is a habitable planet. And it's very interesting because the whole colony is going back to like in reverse, like how can I say it, they go back to like prehistory, like they go in like conflict and
Oh
fight,
yeah,
and there's
true.
merely a
Of
few
course you are.
humans that make it. After generations and
Right,
generations, there are only a mere humans getting to this actual planet and
right.
that happens to be habitable. So it's quite fun to actually test this kind of things and realize that it's such a big gamble. Like it's like
Yeah, right.
I know a few people want to go to Mars. Like I know a few people that
Mm.
I would be happy to see on Mars if they really want to. They can go there, but but no. Overall, no. There's there's no like reasonable option to go on another planet. Like what
Right.
we're doing is just like for the only curiosity.
Right.
Is there life? What is life in the universe? Can there be other planets? But
Mm.
and I'm sure there are other planets. The question is, are they close enough that we can observe them?
Right.
Because if
But then
it's
also like I mean, imagine like leaving behind our beautiful planet Earth for something like Mars.
yeah, absolutely. You do not want to
Makes
be
no
on
freaking
Mars.
sense. Yeah, right.
But even a planet that would be habitable, like we have to understand the concept of habitability. It can be a planet where it's every day 60 degrees
Right.
outside. Like
True.
this would be habitable. A planet covered with like a desert, like the
Right.
Sahara in Africa, would be considered
True.
habitable because there's some sort of
Right.
life
Of
on it.
course. Yes.
Do we really want to live on like such a planet? It's sounds pretty hard. So
No, right.
it's
I
I
know.
think it's very unlikely we find an Earth 2.0 like that would be reachable by space travel.
Right.
Sounds like a gamble to me.
No, it is. No, it is. Yeah, like I mean, I don't have anything to add to this. Yeah, like thank you so much. I feel like this was a perfect description of like how things are. Okay, I mean, I truly enjoyed this conversation. I mean, it was great like conversing with you. It was awesome. I think like this conversation had plenty of highlights and then like very big ones too. But if you think like there's anything that is missing, or if you have a closing comment for anyone who's like listening, do you want to
Like
say
I can say
something?
what's I can say to if people are listening and are interested in astronomy, so I can repeat what I said maybe a bit earlier. It's like astronomy is not a dead end. Like you might
Right,
have people telling you that it leads to unemployment or that like it's like even if astronomy is not a perfect field, obviously it has like it's demanding, it's asking you to travel a lot, to put a lot of work,
right,
but it's never a waste of time to try it if you really want. I always tell my students when they ask me the question, should I really pursue a PhD? Should I really continue?
right,
And I always tell them, you can always try.
right.
Try, and even if you don't like it, then you're free to not continue, but it will never be a waste of time, a waste of experience to try it. So, yeah, I can conclude with that.
No, that is an amazing message. I was hoping like these interviews will actually bring this to light because there are like plenty of people who are saying that postdocs are not worth it. I mean, you're just investing your life and best years of your life in something that is not going to reciprocate your love, your dedication, and the amount of like financial effort that you're like putting into it. But these interviews, I think like from very young people, they have mostly shown that it was always worth it. And mostly
Yes.
people are like um, living the dream that they once had. It's like something like very common that you're like hearing on this channel that like when people were like children, they always want to know more about the night sky and they got the chance to do it. I think being true to yourself and living your dream is something that is not everyone is like privileged to do that. So I think like if
No.
you have the privilege to do that, then yes, go ahead and do it.
Mm. And also, like, it's important to not get carried too much in your work. It's also nice to have
Right,
other activities next to it. Continue reading, continue doing sport, continue
right,
seeing your friends, because that's the problem. Is often the people who are putting too much effort on their
right,
work, who are really not taking any time for themselves, usually end up like in a burnout, or they end
right,
up like disgusted with their work.
right.
So it's
True.
important. We all enjoy our work a lot, but if we want to continue enjoying our work, we need to also take care of us, like take care of
Right,
ourselves in the daily life, because astronomy is very nice. It's very a source of inspiration for
right,
everyone and for us, but we are only humans, so
right.
we also need to take care of ourselves.
Right. I remember one of my very successful friends in astronomy, like she said something memorable in Amsterdam, like in a summer workshop. She said that before being a scientist, we are all human beings. And I think sometimes we really forget that when we like get so much caught up in work because we want to just publish, be productive, and then like go here and there because it's a very exciting field. But yeah, like we are all human beings inside. So, yeah. No,
Yes,
this is like great advice. Okay, thank you so much. I really enjoyed this. Have a nice day.
thank
Ciao.
you so much.